Hey everyone, welcome back to Danis Podcast. I'm so glad you're here, and if you haven't subscribed yet, go ahead and hit that button so you don't miss any episodes. Today, we're talking about something super interesting that sounds futuristic but is already shaping our present: quantum computing. Now, if you're not a computer expert, don't worry, I'm going to break this down in a way we can all understand, so buckle in, and let's dive right in. So first things first, what exactly is quantum computing? To get this, let's start by thinking about how a regular computer works. Traditional computers, like your phone or laptop, process information in a pretty straightforward way. They work with bits, which are like tiny pieces of information. Each bit can either be a 0 or a 1, just like an on-off switch. Imagine if every decision you made in your life could be boiled down to either yes or no. That's kind of how computers work, either a 0 or a 1, on or off, yes or no. But some problems are way more complicated than a simple yes or no. Think about the world's biggest puzzles, like figuring out how proteins fold to develop new medicines, or calculating the safest routes for thousands of flights happening at the same time around the world. These problems have way too many variables to be solved by checking each answer one by one. Now here's where quantum computing comes in. It uses quantum bits, or qubits. A qubit is like a bit, but it can do something that regular bits can't. It can be both a 0 and a 1 at the same time. Sounds weird, right? Here's an analogy to help explain it. Imagine you're flipping a coin. In a regular computer, it would either be heads or tails. But in a quantum computer, it's almost as if the coin is spinning in the air, showing both heads and tails at the same time, until you actually look at it. That's what we call superposition. And this allows quantum computers to consider many possible answers all at once, rather than checking each answer one by one. Another key idea in quantum computing is something called entanglement. Here's a simple way to think about it. Imagine you and your best friend both have a magical set of dice. No matter how far apart you are, when you roll your die, your friend's die will land on the same number every time. Spooky, right? This connection is what we call entanglement, and in quantum computing, it allows qubits to be linked in a way that if one qubit changes, the others do too, even if they're far apart. Einstein called this spooky action at a distance, because even he thought it was strange. But for quantum computers, entanglement is what makes them so powerful. So, why do we even need quantum computers? Imagine you're at a giant library, and you're looking for one specific book, but the library has millions of books and no search system. A regular computer would look at each book one by one until it found the right one. A quantum computer, on the other hand, could look at all the books simultaneously and instantly pick out the one you want. Because it can process many possibilities at once, quantum computing has the potential to solve problems in seconds that could take regular computers years, even centuries. Let's get practical with a few examples of what quantum computers could do. In medicine, they could help us understand complex molecules to design drugs for diseases we currently can't cure. Imagine a computer that could simulate how every possible medicine will interact with the human body. In logistics, quantum computers could help airlines and delivery companies find the most efficient routes for thousands of planes or trucks at once, saving fuel, time, and money. And in finance, they could predict complex markets better than any system we have today. Quantum computers might even help us tackle climate change by helping us design new materials to capture carbon from the atmosphere. So when are we going to see this technology in action? Well, right now, we actually do have some quantum computers. Companies like Google, IBM, and startups are building quantum computers, but they're still in the early stages. In 2019, Google claimed that its quantum computer did a calculation in minutes that would have taken the best supercomputer about 10,000 years. But here's the catch: that calculation wasn't exactly useful for everyday life. Right now, these early quantum computers are kind of like prototypes. They can do a few tasks really well, but they aren't ready for general use yet. Quantum computers have some big challenges to overcome. You know how your computer might get glitchy if you drop it. Well, qubits are 1,000 times more sensitive than that. Any tiny disruption, like a slight change in temperature, can mess with the qubit and throw off the whole calculation. Scientists are working hard to make qubits more stable, but it's going to take a while before quantum computers are as reliable as the ones we have today. Here's a big question. Will the next world superpower be decided by who controls quantum computing first? It's very possible. Governments around the world are investing billions into quantum research because they know it could change everything. Imagine if one country could decode every other country's secret communications because they had a quantum computer powerful enough to break encryption. Or if they could use quantum computing to advance technology, medicine, or military equipment faster than anyone else. This could be as big as the space race was back in the 20th century, where the US and Soviet Union competed to be the first to explore space. This time, it's the quantum realm that's the new frontier. But do we have quantum computers right now, even in a limited form? Yes, we do. IBM, for example, lets people experiment with a small quantum computer online. It's not as powerful as what Google used to achieve, quantum supremacy, but it's a start. Researchers and even some curious high school students can play around with it and try out basic quantum tasks. But these current quantum computers are still in the sandbox phase. They're kind of like the old school computers from the 1950s that took up whole rooms and could only solve basic problems. We're probably a decade or more away from having quantum computers that can change everyday life in a big way. Let's wrap this up. Quantum computing is still a young technology, but it has the potential to change almost everything about how we live and solve problems. From drug development to logistics to finance, quantum computing could unlock solutions we can't even imagine right now. And while we're still in the early stages, the fact that big companies and entire countries are in a race to figure this out tells you how important it is. Thanks for tuning into this episode of Danis Podcast. If you learned something new, hit that subscribe button, share this episode with your friends, and let us know what topics you'd like us to cover next. Until next time, keep exploring, stay curious, and remember, the future is closer than it seems.